Bismillahirrahmanirrahim. Welcome back to my channel. I'm back with another video on GnuRadio tutorial. In this tutorial, we're going to look at a component which is called VCO, Voltage Control Oscillator. Voltage Control Oscillator is readily available here on your Finder block right here. You can also search for Voltage Control Oscillator, and we're going to actually look at this oscillator to actually generate an FM signal. Because my job is what I'm trying to do using GnuRadio Companion is that what are some of the blocks that are there, and how can I use it to achieve whatever task that I have. Why have I chosen VCO? Because voltage, when we're about to implement and we're about to make a circuit of FM generator circuit on breadboards or on PCB, the chip that is required is a PLL chip which contains VCO. VCO is actually part of PLL chip. So what VCO is actually a voltage control oscillator. So let's quickly look at voltage control oscillator. This is how it's implemented in GnuRadio. So what it will do at the input, whatever the voltage you will give, based on that voltage, it will generate me a frequency. So based on whatever the voltage is, it's going to generate a frequency for me. That's the basic idea. So it will produce a sinusoidal wave based on the input. In reality, when you're using GnuRadio, when you're using VCO, you're actually given some type of a DC voltage. So the way I have made circuit using PLL is to apply some type of a constant voltage source. So in order for me to actually use this, I have used a constant source and just calling it a voltage value. So that's why I'm calling it a voltage, and these values are called here in a GUI range slider. Right here at a GUI range slider. Then it went into my VCO. So sample rate is same thing as whatever the samples which are coming out. Sensitivity, this term is actually defined what is the maximum frequency range it will produce. Actually in GnuRadio, it's sort of like frequency deviation. So sensitivity is sort of like frequency deviation. It's like what I have seen it to be is actually what is the frequency, because when you are actually firing up a chip on a breadboard of a VCO, it has some instantaneous frequency or free running frequency. Then once you change the amplitude, it actually moves away from that. So that sensitivity is this. You can choose any value. It will lower. The higher the sensitivity, the more the variation you will see based on the voltage. And this is just amplitude, so I'm going to change this amplitude. Based on the amplitude, it will actually produce me a frequency. Then it went into a throttle block, and then I'm looking at this signal in time sync and also in frequency sync. I can also do a complex value, but I'm just looking at the real values. So let me just simply run this flow graph. Let me just zoom out and let me just run this flow graph. Once I fire up this flow graph, alright, what you're supposed to see right now, there is no change. So there's some frequency which is there. If I have no amplitude, which means there is no frequency, there's nothing which is being generated, and at the output that you are seeing right here, this is just that DC component. All right, so this is your DC signal that is 0 amplitude, and that's it. There's nothing there. So this is some DC component. Now when I start changing the frequency, let's imagine this in terms of frequency modulation. In frequency modulation, what's going on? You have frequency which is expanding, and you have frequency which is compressing. These compressed part of your frequency is actually higher frequency component, while the expanded part is actually a lower component. So I can actually depict that by changing my slider, which is associated with my voltage value here, and by just changing it, you can see I'll start producing frequency. Now if I just do it quickly, you can see you have a high frequency component, then you have a low frequency component. Definitely when you increase voltage, there is high component, and there is decrease in voltage at the VCO, then there is low component. This is actually what's going on in an FM modulated signal. You have low frequency component, high frequency component. But in FM modulation, we were controlling it using some type of a modulating source, But here I just wanted to show you a functionality of VCO. That's why you can use a slider to actually check and see. So now it's supposed to give me a voltage it's supposed to give me a frequency based on my voltage value. So you can check and see, yes, indeed it is. So I'm generating at about 2.6 volts. It's giving me about 6.19 kilohertz of frequency. As I increase my frequency to about 10 kilohertz, and I'm getting somewhere around 23 kilohertz of frequency. Even though my signal is being compromised, you can see a change in amplitude, but that's the basic idea behind voltage control oscillator. Is once you change your frequency based on your change in based on change on your voltage, you will generate a frequency signal. So next step, what I've done is actually take a signal source, which is a normal sinusoidal signal source that has a frequency of 1 kilohertz, and that I have just plugged it into my VCO, and I'm just looking at a graph. Now let me just hit the play button and let me just show you how does a output signal looks like. So definitely, as you can see, because we were manually controlling it last time, so we won't see. So this is how we were manually controlling it to get the change in my frequency, which was actually the deviation of my frequency. Now, when I closely look at the spectrum of this, isn't that look something similar to like an FM signal, where you have your carrier frequency, which is at around 0, and then this is some value FC plus FM, FC plus 2 FM, FC plus 3 FM, and so on. Because the frequency spectrum of a frequency modulated signal, it's actually like this. So this is just to show you how you can use a VCO to actually generate a variability in your frequency based on whatever the input voltage is. Either you can control it with a constant source, just like I showed you before, and this is normally what we do in circuits as well. And you can also use a sinusoidal source, and that sinusoid will automatically change that amplitude, and that's why you are seeing the spectrum as compared to a constant value spectrum where the frequency was moving as I was increasing the voltages and signal. But here it's done through your signal source, which has a sinusoidal signal of 1 kilohertz. So I hope you like this small tutorial, and if you have any questions, leave it in the comment section, and don't forget to like and subscribe to my channel.